Okay, so in this video we'll be looking at adding Poisson distributions. It's quite a simple method because if you want to kind of combine the x and the y term, then all we do is add the means. So you can see here, lambda, add new, when we add x and y. So we'll just do a few examples and it'll become a lot more clear. So starting with the first example, so if we want to do adding x and y, then we do x add y, Poisson 3.6 add 4.4, this is equal to 8, so if we just rewrite that, x plus y, Poisson 8. We could also rewrite x add y as m, just to make things simpler. So m is the Poisson of 8. Then we want to do the probability that x add y or m is equal to 7, so probability that m is equal to 7. We can just plug this into our calculator and we get 0.1396. And for this example here, probability that x add y or m is less than or equal to 5. If we plug this into our calculator, on Poisson CD we get 0.1912. So for the second example, which is more of a modelling example, the number of cars passing an observation point in a 5-minute period is modelled by a Poisson distribution with mean 2. So we can do Poisson distribution mean 2, where x is equal to number of cars passing in 5 mins. And then we have the number of other vehicles passing the observation point in a 15-minute interval. If you can see here, the first distribution we had a 5-minute interval, so the 15-minute interval is modelled by a Poisson distribution with mean 3. So at y po 3, where y is equal to number of vehicles passing in 15 mins. So find the probability that exactly 5 vehicles of any type pass the observation point in a 10-minute interval. So to get from 5 minutes to 10 minutes, we double x. So 2x, and this would be 4. And then we'd have to get 2/3 of y, which is 2. So we have 2x add 2/3 of y is equal to, the contents, so 4 over 2, which would just be 6. And so exactly 5. So what's the probability that 2x add 2 over 3y is equal to 5? If we plug this into our calculator on Poisson CD, we get 0.1606. So for part B, it's asking us find the probability that more than 8 vehicles of any type pass the observation point in a 15-minute interval. So for the other vehicles, the distribution already displays the mean number of vehicles passing in 15 minutes, so that can stay as it is. But this is for 5 minutes, so we need to times it by 3, so 3x 6. If we add y, add 3x, we get 9. So more than 8 vehicles, probability that y add 3x is greater than 8, or the probability that 1 minus the probability that y add 3x is less than or equal to 8. And if we plug this into our calculator, we get 0.5443. Okay, so for the final example, during a weekday, a certain point of the road, cars pass by at a rate of 24 per minute, whilst lorries pass by at a rate of 8 per minute. So as we usually do, we'll start off by defining and writing down our distribution. So x po 24, x is equal to the number of cars passing per minute. And then for lorries, y po 8, y is equal to number of lorries passing per min. So for part A, find the probability that in any 15-second period, at least 4 of each type of car passes by. So this is a 15-second period, so we want 1/4 of each because we've got a minute. So 1/4 of x is equal to 6. 1/4 of y is equal to 2. And so the first part is at least 4 of each type of vehicle passes by. So we want at least 4 cars and at least 4 lorries. And so to do this, we'll find the probability that we get 4 cars times by the probability that we get at least 4 lorries. And so to do this, we have 1 minus the probability of 1 over 4x is less than or equal to 3. 1 minus the probability that 1 over 4y is less than or equal to 3. And the answer to this, if we plug it into our calculator, we get 0.848796. And for the lorry part, we get 0.142877. And as I said, if we times these together, we get 0.1213. So for part II, it says, find the probability that in any 15-second period, the total number of cars and lorries that pass by is no more than 9. In this problem, it says the total number of cars and lorries, and therefore we use our addition formula. So in 15 seconds, 1 over 4x add 1 over 4y has a mean of 8. And the total number of cars or lorries is no more than 9. So we want the probability that 1 over 4x add 1 over 4y is less than or equal to 9. And if we plug this into our calculator, we should get 0.7166. The final part of the question is write down one assumption that we've made in our calculation. We could say that we assume that we're using a Poisson distribution and the cars are coming through at a constant rate. Another assumption that we could say is that our cars and lorries are, the rate at which they're coming through is independent, perhaps there's no traffic congestion. And so yeah, that's the basic premise of adding Poisson distributions.